Hello and welcome. Today we're going to show you all the basics you need to know to get started in GAUSS with choice modeling. We'll cover all the fundamentals: importing data, cleaning and exploring data, exploratory data plots, creating new variables, and estimating a binary choice model. Let's get started by loading some data. First, we'll set our working directory to the location of our data. Notice that the current working directory shows up in our Project Folders window. The Project Folders window is a useful GAUSS tool. It allows us to access all the files that are in our current working directory, as well as any custom project folders that we've added. Today we'll be using the McMaster Commuting Dataset from Whelan et al. 2013. The dataset provides information on mode of travel to McMaster University in Hamilton, Canada. Let's double-click on the MC Attributes CSV file to open it in the Data Import window. Now let's look at the variables in our dataset. The Variables list is a useful import tool that allows us to view and control variable names and types. The first variable, x1, counts the observations. Let's remove it from our variable list. Let's also change the name of the data frame that GAUSS will create using the Symbol Name window. Some of the variables in this dataset use NA for missing values. By default, GAUSS only recognizes the dot and blank cells as missing values. We can specify other values or strings to be identified as missing using the Import Options tab. This dataset contains a lot of variables, and not all the variable names are visible without scrolling. Fortunately, the Filter tool lets us quickly search our variables. For example, let's look for variables related to the walk choice. We can bring any variable into view using the drop-down next to the variable name. Now we're ready to import our data. When we click Import, GAUSS will load the data and take us to the Data page, where we can double-click the name of our data frame in the Symbols window to view the loaded data. Notice that all the code used to load our data and convert the NAs to missing values is available in the Command window. We still need to load our second dataset, mccommuteChoice.csv, which will load into a data frame named Commute Choice. This file contains an ID variable along with the transportation choice variable. Let's view both of our data frames side by side. Next, we'll use the Variables list tools to learn more about the properties of the categorical choice variable. If we expand the drop-down window next to the choice variable and select Properties, the column mapping window opens. This window provides a quick tool for spot-checking how categorical variables are coded and if any category labels need updating. Unless a dataset provides information about the relationship between key values and labels, GAUSS assigns key values in alphabetical order. That means that for the choice variable, the category car is assigned the key value 0, making it the base case. Let's update the base case to be the walk. This can easily be done by selecting the walk label from the list and moving it to the top of the list and clicking OK. When we do this, we see that additional code has been generated to reclassify the choice variable. It's always good practice to save your analysis steps in a program file for verification and reproducibility. Let's go back to the Edit page, where we can find the code that was auto-generated by the Data Import tool and create a program file for our analysis. It's a good practice to start all your programs with new and CLS. These commands clear all data from the GAUSS workspace and clear the output window. Starting each program run fresh can prevent a lot of errors. Notice that the code created in the import window uses the full path to load the file. If you don't include the path, load D will look for the file in your current working directory. Formula strings are a convenient way to specify which variables you want to load, as well as their types or any transformations you want to make. Dot means all variables, so the formula dot minus x1 tells GAUSS to load all the variables except for x1. More details on formula strings can be found in the description below. You can open the Help for Load or any function by right-clicking and selecting Help on Selected Text. This will open the command reference page that shows you what inputs the function takes and provides examples of different options. As is often the case, our data came from different sources, but we'd like to merge them into a single data frame. We can merge our data on the ID variable, which is included in both data frames, using the outer join procedure. Let's add this to our program file. The default option for outer join is a left outer join. This means that all observations from the first variable passed in will be kept, even if there's no matching observation from the data on the right. However, if there is an ID in commute attributes that is not in commute choice, it will not be included in our final data. After running the file and merging our data, we can conveniently view our new data frame from within our program by placing our cursor on the symbol name and using the Ctrl+E hotkey. In the preview, we can see that the choice and attribute data has merged. Let's now confirm that our ID variable is unique using the isUnique procedure. The return of 1 tells us that it is. Now that our data is merged, let's take a look and explore some summary statistics using dstatmt. The dstatmt procedure produces a table with the mean, standard deviation, variance, minimum, maximum, and counts of valid and missing observations. One observation from the table is that the ages of respondents range from 17 to 60. Suppose that for our analysis, we want to focus on individuals 25 and under. We can use the Data Frame Manage tool to filter the data and remove all other ages. After setting up the filtering conditions, we need to apply our changes. We can see that the total number of observations reduces from 1375 to 1224. The Data Management tool generates the code for our filtering, which we will copy and paste into our program file. Now that we've filtered our data, let's explore the frequency of the choice variable outcomes using the frequency procedure. Our frequency indicates that walk makes up 55.6% of the transportation choices. If we want to dive deeper into the relationship between the choice variable and other categorical variables, we can use the tabulate procedure to create two-way tables. Since we only want to see the report from tabulate, we can use the call keyword to tell tabulate we don't want any data returned. The tabulate function uses formula strings to specify the variables included in the table. The variable on the left-hand side of the tilde is the row variable, and the variables on the right-hand side of the tilde are the column variables. One final convenient tool for exploratory data analysis with choice data is the ability to generate summary statistics by groups. This is particularly useful for exploring the relationships between categorical variables and quantitative variables. For example, let's look at the summary statistics for street density by transportation choice. To do this, we use the dstatmt function with the by keyword. Here we can see the descriptive statistics of street density for each value of choice. The summary table gives some insight into how the street density varies with transportation choice, but it might be helpful to have a visual. We can use a scatter plot to see the relationship between street density and sidewalk density. The by keyword allows us to color code the observations by transportation choice. We'll start by going to the graphics page and opening the command window. Notice that when we plot using formula strings with the by keyword, the y-axis is automatically labeled, the legend is automatically generated, and the symbols are drawn in default GAUSS colors. While these are good defaults, let's modify the graph sum for better viewing. First, let's focus just on the walk and cycle choices. We can remove the other observations from the plot using the legend to deselect some of the series. Next, let's use the Graph Settings tool to format the graph. We open the graph editor through the View menu and by selecting the plot. The Graph Settings tool groups graph settings together based on graph features. For example, all settings related to the graph title are found in the Title group. Let's use the Title settings to add a title to our graph. First, we'll double-click on the Caption option to open a text box. Our title is added to the graph, but it's too small. Let's use the Title Font Settings dialog to change the size of our title to 18. The Graph Settings tool is a great way to interactively modify a single graph, but it isn't always convenient if we have multiple graphs we want to customize. All graphics options can also be set programmatically, which allows them to be easily replicated in the future. Since our data is survey data, we also may want to visualize the frequency of our categorical data. This can be done using the plot freq procedure. Now that we've explored our data and performed preliminary data analysis, suppose we want to start with a preliminary model of the binary choice to walk or not walk. We can generate a new variable, choice walk, based on our original choice model. To do this, we will first use a conditional statement that checks element by element whether the choice variable is equal to walk or not. In the conditional statement above, the dot tells GAUSS to look at each observation in the variable choice, and the equals equals says to check if it is equal to walk. This statement generates a vector that has a 1 if an observation equals walk, and a 0 otherwise. We can convert this to a data frame using as_df to convert from a matrix to a data frame and add a variable name. We'll also concatenate it to the front of regData data frame using the tilde operator. Now let's rerun our file and preview the first 5 rows of our data with the head command. Finally, we'll use the Data Management tool to update the type of our choice walk variable. Once we change the type to category, we can update the category labels from 0 to not walk and 1 to walk. Don't forget to click Apply after making changes. Now that we've completed our data cleaning, it's useful to save our cleaned data for later use. This prevents us from having to always perform these data cleaning tasks before other steps in our analysis. Let's save the reg data to GDAT file named transportation.gdat. The GDAT file is a GAUSS data file type that saves all data frame features, including data types. We will save this file to our working directory, where our original data is also stored. Our working directory refreshes in the project folder window to reflect the newly saved file. We can double-click on the file to preview it. Notice that Save D saves all the characteristics of our reg data, including variable names and types. Finally, we'll finish up by estimating a simple probit model examining the decision to walk as a function of sidewalk density and gender, using the data from our transportation.gdat file. Let's create a new program file for this. In our data prep file, we used the full path to specify the file we wanted to load. While that works, it will have to be changed each time you share it with a colleague or move it to a new computer. To prevent this problem, we can use file_dir, which returns the location of the program file that references it. Now we can use the string combine operator to add the name of our file to the end of the path, like this. And we'll quickly add the code to load our dataset. We'll estimate our model using the GLM procedure. Let's go find the help page for GLM. This procedure is a flexible linear model tool that allows us to specify the distribution of the dependent variable. We can see from this page that the GLM procedure allows us to specify our model using a formula string. Use a string to specify the distribution family of our dependent variable. Use a control structure to specify the link function. If we scroll through the examples, we're able to find a probit model example. We'll copy and paste this example as a template in our program file. We need to update the name of the data frame we're using and modify the formula string to reference the correct variables. Now we're ready to run the model. Once we do, a full results report is printed to screen. This report shows there were 1,224 valid cases. Gender is automatically included as a categorical variable, with man excluded as the base case. Thanks for watching! Today we've looked at the fundamentals that you'll need to get started with choice data in GAUSS. We've covered importing data, exploring and cleaning data, data plots, creating variables, saving data sets, and estimating a basic probit model.